All right, welcome back everyone to Man Watch Required, the inspection podcast. It tries to shed some light on the inspection industry while making it entertaining at the same time. A bit of some unknown secrets that we like to share with everyone. On today's episode, we're going to attempt to wrap up turnaround. We'll see how that goes. Start with a brief recap of last episode and maybe some quick kind of overall of the whole turnaround process. Then we're going to move into some repairs, some of the difficulties there and how that processes through, and then closures if we get to it. And basically that's how you finish your turnaround with closing the Manways. So sit back and enjoy. Frank.
Scott, we're back.
We're back at it. How you doing?
Good. We got the mystical Matt in studio finally. Eight episodes deep, hey?
Yes, finally. A nice treat for the listeners because they've been so good. Another special guest that we've been talking about almost every episode.
Matt, how you doing?
I'm good, Frank. Thanks for inviting me along today. And Scott, nice to meet you.
Nice meeting you finally. Lots of talk, but first meet up, so we might as well record it, see what happens.
Yeah, no, we had some good talk at the beginning, and as we were populating our whiteboard of wonder there, so let's kick it off. Scott, I think you want to do a little recap of the last episode, or you wanted to. You don't necessarily have to talk it out, but...
Yeah, I don't know. We don't have to kill too much time on that, but we might as well try to recap it. We did, as again, didn't listen to the last episode, so we'll try to remember what we talked about. I think a big one on the last episode was the whole day shift, night shift battle, and having I say battle, it's not always a battle, but having multi-inspectors doing reporting per manway, that type of thing. Just gave some of our input on what works, what doesn't work with that. Leaving the breadcrumbs is, I think, the biggest takeaway from that, especially when you're doing, the towers and stuff like that, where you got, upwards of 10 manways and you're only expecting 1 or 2 of them per shift, that type of thing. Leave some good notes for not only the guy working with you, but also your cross shift too, right? Don't leave them out to dry there, so to speak.
Yeah. Matt, any thoughts on any of those recap topics?
Oh, no. I mean, I'm with Scott on the breadcrumb theory for sure, and a good handover to your partner.
Yeah, it's always very important to do, and as concise as you can be. And I think we kind of touched last time is try and give a handover to the same quality that you would expect to receive a handover. So that's kind of a good rule of thumb there to start out with. Scott, I think we're going to touch on one of your favorite subjects right now. This episode is repairs.
Yeah, definitely what keeps me interested in this industry for sure. But I don't know, before we get too deep into that, maybe we'll let Matt introduce himself before we get too far ahead and just assume everybody knows who he is.
Yeah, no, definitely a good idea. Matt, why don't you tell us a little about yourself?
Sure. Well, I'm Matt. I met Frank, I don't know, almost 10 years ago now, I guess.
Yeah.
And I'm a pressure equipment inspector, and I work for an own user company here in Alberta. And yeah, my day-to-day function is unit inspector and sometimes the lead inspector on turnarounds as and when they come around. And I'm responsible for ensuring all things to do with pressure equipment go well and we keep things safe.
Nice.
And you're a staff inspector too, right, Matt? So that kind of provides a little bit of a different insight than me and Frank like to offer up every episode. So this will be interesting back and forth, I'm expecting.
We've already had some good conversations off air.
Yeah. So hopefully that spills over. We'll just continue with that. Yeah.
Yeah, no, I liked it. I like especially just meeting tonight. I think you guys, I knew you would mesh really well, so I'm excited I'm just going to sit back and listen to this episode, I think.
Yeah, just going to be a listener.
Probably provide better information than I've already been giving. So anyway, so one thing we didn't really get to touch on last episode was the repairs. Like we talked a little bit about reporting and stuff, and we talked a little bit about some corrosion assessment, like maybe trying to find some remaining wall and ways to find that. We talked about maybe some adjacent UT thickness measurements to complement your pit gauge measurements, or even some external UT scans to kind of find out what you exactly have for remaining wall. And trying to figure out your corrosion rate and to see if you actually need to repair it or if it's going to make the next turnaround cycle and operate safely. So what do you guys think?
Yeah, I mean, that plays a big part of it too. Jumping back a little, back and forth a little bit on our whiteboard, but like determining your corrosion rate, what your corrosion allowance is, your team and all those things, that's going to play a big part in deciding if you have a repair to do or if it's, something that can be left for the next run. We kind of talked about that offline, but those are all important things. You talked about the adjacent UT and subtracting the pit depth. That's one of my favorite things to do. I find it works very well. Obviously, the external UT scan is probably the best thing, but you don't always have that option. What about yourself, Matt? Any preference to those two? Maybe a different method we didn't talk about?
Yeah.
No, I agree. I mean, one point you bring up about the UT externals, I always try and take the opportunity with an internal inspection to validate that my UT placements are actually on point and monitoring corrosion. So for us, we're a pretty new facility there, and we had assigned our UT locations based on theoreticals of where you may hope to see corrosion or expect to see it. And it was already turned out that on an exchanger, well, the areas we're monitoring aren't the areas that are corroding.
Now, is it more so like you guys have been previously trying to find or taking thickness measurements at readily accessible areas, we'll call them, or was the corrosion you found like somewhere that was kind of hard to get to, or just somewhere you guys didn't expect that kind of degradation, I guess, to occur?
Well, no, so on the exchanger, it was on the underside,
Yeah.
so on the bottom. It was just port placement. I mean, we got probably 16 feet between the inlet nozzle and then the wear plate. This is a shell and tube kettle exchanger. And just the port placement was, about 20 inches out.
Oh, yeah.
So on our theory, we were showing no loss, but on our first opportunity to do the inspection, we find pitting.
Mm-hmm.
So for me, not necessarily get rid of the port that you've already got, but just make new ones and expand your survey for next time around.
Yeah, I know that's actually definitely a good thing. So that's something that you guys probably either plan to do just on-stream inspections to kind of monitor and that maybe even validate your actual corrosion rate that you've kind of got, right? So like you may have assumed, since you didn't have this is actually something that actually might be good. So you didn't actually have any previous thickness locations there, but you might have had some adjacent ones. But when calculating your corrosion rate, right, you might have some different data and you might be forced to actually use a long-term corrosion rate because you can't really validate what it was originally within that area, even though plate is generally 10th thou variance from the mill. Yeah,
no, for sure. That is a good point. But I just think, a lot of UT points, go back to your comment about being readily accessible. I would say 80% of them are probably placed as such.
Yeah.
Bearing in mind time and cost of doing the exercise. I just think, you got a tower that's 200 feet tall and you can stick 30 UT points on it. The chances that you're finding the spot that you want to monitor are pretty slim.
Yeah, true.
So and that's kind of the whole needle in the haystack theory, right? And that's a big benefit with equipment is, pressure vessels and whatnot. You can go inside there and back up what you've been doing and, see that you've been doing it right or that you've been totally missing, right? Each one is beneficial, but that's kind of the big advantage equipment has over piping. You can't go inside piping and validate what you're looking at. So yeah,
no pipe ever leaks at a UT point.
That's right. Yeah.
Just smother a UT point should be good.
Yeah. Well, that goes to actually knowing process and when you're actually setting up, like if you are lucky enough to set up a corrosion monitoring program at a facility or kind of maybe have your hand in, I don't want to say like not maybe altering it, but enhancing one that's already existing, like working with the corrosion engineers or even the operators who are knowledgeable with the process, like that's definitely going to add value and might change a few spots where you originally thought you would put some CML locations, right? And talking to these guys, especially the corrosion engineers, or process engineers actually even, they'll know exactly what's happening in that piece of equipment and even in the piping in between pieces of equipment, because realistically piping goes from one equipment to another piece of equipment or an equipment exchanger, whatever it is.
Yeah, I just think it's, for me, any internal inspection is a good chance to validate what you're actually doing outside of turnaround is, accurate and true of the condition that's happening.
Yeah.
So,
Yeah, that's a great way of putting it. I mean, it's especially when it's a new piece of equipment to a new facility. Like a replacement's a little different because you kind of expect the same things, but when something's new at first, you're kind of taking a guess at it, educated guess, I'll say. It's not a total shot in the dark, but you are taking a bit of a guess, and then that internal inspection is a great way to back that up. Like, okay, let's see how we done here, and how do we need to improve this, or are we good? That type of thing.
Yeah. Okay. Let's. You guys want to start off with the first kind of item on the whiteboard there, creating repair plans. So I guess picking up from the last episode, we've done our inspections, we've started to populate our report, and we've noticed that, hey, we have some damage here that is going to need repair. So where do you guys think you would start there?
Well, for me, I think the first thing is documenting it.
Yeah.
So, I listened to I've listened to all your podcasts before there, but, you're marking pictures, documenting size, areas, depths, and truly understanding the scope of the repair at first.
Yeah, that's a good point.
So,
Yeah, especially those kind of repeat offenders too, right? Where you're continually repairing the same spot over and over again. It's good to have that good history. And then, I guess from there, once let's say we've already established our corrosion rate and our T-mins and our fitness for services out the window and those type of things, and we are into repair, the first thing you want to do is get something written up, run it up the engineering tree if that's how your facility does it, or maybe the inspection group does it, whoever it is, but you want to get that on paper and get that to your contractors, and they'll start putting together their documentation, their ITPs, get those in for approval. Maybe they'll have some input on how to do the repair, that type of thing. And that's kind of the first step before you get too excited about doing the work, is getting all that in place and having that back and forth.
Yeah, you actually said something there pretty good, is actually kind of determining if it does need a repair, right? Because even if you do find, let's say, linear indication.
Nice choice of wording.
Yeah. You can excavate it. And what I mean by that is remove some material and try to remove that indication. And you may not actually have to build that back up. And this was a little discussion we had before we hit record there. You need to determine, what actually, sizing it kind of beforehand can be kind of tricky. You can do some shear wave or some maybe advanced NDE to kind of see the depth and maybe how much material you're expecting to remove, but it doesn't always go according to plan. Depending on how they're excavating it, it could help propagate that indication a little bit more. But once you get it out, you do want to definitely validate your corrosion rate within that piece of equipment and see, is there any corrosion allowance left? Or, sometimes the engineers or somebody else may not want to actually do any well buildup on that piece of equipment and say, you know what, we've done the calculations. The actual minimum thickness is X number, and given our corrosion rate, like, we can leave it for the next turnaround cycle and even just monitor it on stream if we actually have to, right?
Yeah, that's a great point. And a lot of times welding you can do more damage with that too, depending on the process and the materials and those type of things. So I think this would be a point of interest for some of the quality control people, some of the Boilermakers, that when we do things like grind indications out of a vessel and leave it, you always get those questions like, we can't leave this. It's got to be brought back to new. Well, yeah, in an ideal world, sure, but is that going to really make it any better or make a difference? Sometimes not, right? So it's just wasted effort, potentially creating more damage, maybe creating a mechanism in itself there. You could be bringing it into postal heat treat and things like that, where if, you don't really have a corrosion rate, and like Frank said, you have nominal corrosion allowance left, or you have a long ways to go till your T-min, there's really no benefit to doing the weld buildup. So that's where you go back to your documentation. So next time you're in there, you look at the last inspection report. Okay, we're expecting all these little boat samples all over the place, and not to be too alarmed, right? That's something you'd want to expect. I'll throw in a quick story here on exchanger shell I just looked at recently. All along all the long seams, I think there was 3 of them, I believe, 3 shell courses. I want to say like 2 spots in every long seam, there was like a 6-inch by 2-inch, like kind of looked like a worm-like corrosion, like rectangle shape. And I was like, man, what is this? Like very, very bizarre, right? And me and the materials, the corrosion engineer were kind of talking about it, and the facility we're doing this turnaround at, they're big on like the markers and the different colors corroding and that. And we're like, well, it is spot RT, and that would be like the perfect size for where a piece of film would go, right? And I'm like, okay, this is kind of making sense. And then I just started digging back through some more and more reports. I don't think it was the last time, but it was like a couple times before. They had found some linear indications, as we like to call them. And they just did some odd pencil grinding. Instead of like using a pencil grinder with a carbide burr and just digging it out in the one spot, they just kind of took like toothbrush style and like all along and made this very odd kind of grinder marking. And it was noted in there like to expect this because it was obviously a strange looking, well, it ended up being grinding, but strange looking. Like it looks like a corrosion spot in a perfect rectangle. So it was bizarre. We thought we were onto some really cool thing where the chloride in the markers actually caused this, but no, ended up being grinding. But it was interesting for a couple of shifts, anyways, till we found out further what it actually was.
Oh man, if it was the chlorides in the paint markers, the engineers would have like a field day. They would love that.
Oh
right?
man, thered be a cake, big celebration.
My God.
Finally, we've proven the theory.
Yeah. So
must have been a yellow marker, no doubt.
For those unaware, sometimes the paint in an actual paint stick, like we use paint markers to mark on the metal surfaces, obviously. Some of the different colors have different chloride contents, and why am I always stuck explaining this crap? I always get it wrong. But
we just sell you to the dogs.
Yeah. Depending the chloride content, like it may have adverse effects. It's typically on 300 series stainless steel, or steels that are salt sensitive, that it may cause some stress corrosion cracking and stuff like that. So.
Yeah, and depending on the process too, right? It all plays a part. Do you have anything unusual like that at your facility, Matt, where they like one color over another or one brand over another or anything like that?
We do have some color choices, yeah.
Yeah.
Can only use yellow and white.
Yeah.
Yellow and white.
Yeah.
Yeah, it's funny. Some places are black and white. Some places are yellow only.
I'm pretty sure it's yellow and white. But we have, when it comes to chlorides from past experiences, we are super sensitive.
Yeah.
Yeah.
Oh, yes.
Those grease sticks, like those.
Oh, those are the best.
They are the best to write on everything.
Thing ever.
Man,
write on anything, dirty, clean, whatever.
They show up on the pictures perfectly.
Any material, stainless, carbon, whatever shade it is, just shows up beautifully.
Yeah, back of people's coveralls is whatever you
Anything.
need.
Yeah. Oh, I love those grease pens. Yeah.
Yeah. So
great thing.
Anyway, try and determine whether or not you need to actually do a repair first, and validate that obviously before you kind of slough it off as like this doesn't need to be repaired, because there may be some different process things that could happen and stuff like that. But you want to validate your corrosion rate with your remaining wall, and at least make sure it'll make the next I hate saying it like that, make sure it'll make the next turnaround run, but make sure it's remains safe to operate. And actually, even this is going to be paraphrasing on this one, like the definition of repair in like 510 and 570 is to bring it back to a safe operating condition. Like it doesn't have to go back to new nominal thickness or anything like that. It needs to be made safe and be able to handle the process conditions. And that's technically a repair.
Yeah, you're not bringing it back to new construction. No. I mean, you replace the equipment that's back to new, but repairs, that's not the intent. Sometimes that is what happens, but that's not the idea, that you're bringing it back to new. Safe operating condition. That's exactly how you want to put it. And some places too, like you start welding on stuff, they want you to hydro test it. So now you're bringing that, into the equation as well. So, I mean, it's just a lot of things to look at and kind of really weigh the choices there.
Yeah. Actually, when you're talking about that exchanger and it had the Spot RT, we had another exchanger. Actually, it was a very strange design. It was a split bundle, and it had a baffle running almost the entire length of the shell. But
it's not strange.
Well, the design was, so they had cut the shell in half and then inserted the bundle, and then they had the joints there, right? And those were Spot RT, and we did find some linear indications on some of the welds. And then their first instinct was, well, we're going to start shear waving all the other welds. And I was like,
Bad idea.
Yeah, exactly.
Horrific. We've been burnt on that one already.
Yeah.
Through construction NDE, and that for me, that's a big one. A lot of things will get RT'd when they're built new, and then once they're in service, we love in phase array and time of flight and shear wave, and then we seem dumbstruck when we find things.
Oh,
And,
yeah.
well, it's not fair either, right? Those are two different methods. They find
Absolutely.
two different things. If you want to scrutinize it to the level of shear wave, do that at construction. Otherwise, you're just asking for trouble, right? You're just going to find things that you didn't know were there. Now you know they're there. So now you have a decision to make.
Well, that's just it, right? Is, for me, be more cognizant both at the design phase and once you're in service and inspecting equipment, what was the original NDE done on this?
Yeah. And it's tough to, once they find something and it's reported, like you need to kind of assess it and determine and justify why you're not fixing it.
Absolutely.
Right?
Either way.
Yeah. So something to keep in mind, if you're finding surface breaking indications and stuff like that, and we didn't have access to the rest of that exchanger shell because of just sheer size of it, right? I think it was already only an 18-inch, and then you throw a freaking 20-foot baffle down the middle of it, like you're not going to crawl through it, or you're not going to be able to do too much mag on it or any, you know what I mean? So you could have just kept it to mag to where we could reach and kind of go from there. But even then, I'm already kind of saying too much, because then you're wondering what's happening in the rest of the vessel shelling on those welds, right?
Yeah, but you don't know, which is a difference than actually knowing. And not to pick on RT either. It goes both ways. UT has a hard time picking up tungsten inclusions and things like that where the velocity is similar. So it goes both ways. It depends what you want to find.
Yeah, well, we ended up doing I think the last portion of the shell, probably was a 2-foot section where before the head was there, we shear waved all of those, or we did phased array or something like that. And actually those were all clear, right? And we did the circumferential and long seam portion on that can and around the head, and it was fine. So obviously it was the joint design, it was spot RT on that, and I hate to say it, I don't know, sometimes in the shop when they know it's a spot RT vessel, they're gonna sometimes weld it like it's a spot RT.
Oh, come on, don't say that now.
Well, it's miraculous that all the RT shots passed on it, right? All the places they picked.
That's something the tank places do, not the vessel shops. Come on now. Mark out the spots before you weld them.
So something to think about when assessing stuff and when you do find stuff. What do you think we should talk about next year on the board, guys?
Well, we got our big bad regulator here, so I don't know. What do you want to say about them? I mean, one thing with repairs is, regardless of, now this is speaking for Alberta, so I'm assuming there's one or two people outside of the province or country listening, but in Alberta, regardless of your owner-user program, the minimum is going to be that you notify your regulator of repairs you're doing. And that doesn't mean that they have to approve that or give you the thumbs up or anything. You just, for the most part, shoot them an email. I think in a previous episode, I mentioned doing a spreadsheet for known and expected repairs coming to turnaround and just getting a whole...
Yeah, you did. I really liked that one.
Yeah, right? That's a good method I like to do, right? Just knock out a bunch right away. Like, this is what we're expecting to do, and this is what we know we're going to do. Try not to bother you again. That type of thing. So something to keep in mind when these unexpected things come up. Remember that notification is all part of it too. Like, assuming you have a good relationship with your authorized inspector, your ABSA safety codes officer, they're probably not going to get too upset with you if you submit an AB40 and you maybe forgot to give them that notification, but try not to go down that road. So that's, I think, the first step to pulling them in. And then it depends on the repair, right? Really significant ones that have to get surveyed and whatnot may involve them. Things like flush patches and whatnot that maybe aren't part of your owner user cap, they have to certify, probably want to witness the hydros, things like that. So you want to make sure that you, one, notify them, and then two, know their involvement and make sure they're part of it, right? They may have to be in the approval stage. They may want to see some hydro testing if you're going there. They may want to review NDE and then ultimately certify that AB40 document. In some cases, in a lot of cases, you'll be doing it in-house with your own in-service inspectors. So that's just kind of the first thing, getting the info ready for the repair contractor, but don't forget about your regulator too. They got to be pulled in there, maybe just minimal, but maybe to the full extent as well.
Good comment, Scott. All I'd say on that is a cheeky one, and the time to ask for lots of repairs is when it's your ABSA audit of your own user program. That's when you flash your laundry list and be like, we want to be able to do all these things. Yeah. And they'll let them cut it down for you and not be at turnaround time. Be like, please, sir, can we do something?
I think my little 2 cents would be make sure your repair organization is authorized to complete those repairs as well.
Yeah, that's a big thing too. Yeah. Great pickup, Frank. I know we talked about that way back in piping or something, but yeah, same thing. You want to make sure they're authorized to do those repairs, and they're going to do them for you. Like bundle swapping is a big thing. Companies get scared, think they're taking the onus for fabbing the bundle and all that because they have to do an AB40 for the install. No, that's not what the intent of that is. So just make sure that everyone's explained the process and they feel comfortable about it, and yeah, that they're certified to do the work. Absolutely.
Yeah. Geez, we do have that. That was actually the next thing, is certifying. Actually, certifying the vessel is different from repairs. Who wants to start? Kick that one off, maybe. I guess, well, you're under your cap, right? If whether you're able to certify the repair versus complete the repair, just like we were talking to. And even there is some things that the owner user might not be able to do that the repair company can do because they're executing that kind of work. I know the facility that we're working at now, we can't accept the NDE that the repair organization is completing during the repair of the equipment, right?
Yeah, some places can't do anything and they rely on these contract companies to do the work for them. Now, you can certify the repairs as an olive branch of ABSA, if you will, as the in-service inspector for the stuff that's approved on your cap. So you got to know where those lines are drawn too. Just because you can certify, well built up on a shell doesn't mean you can do Section 8 work with your tradespeople you have on site. So make sure you know the boundaries there, because a lot of times you're going to have to use that repair company to do the work. Then you're going to certify it, and the only ABSA involvement is the notification and the submission of the AB40 form. So just really know where those lines are. Those are two different things, what you can certify and what you can actually do.
I think a good one here in Alberta to pick up on is the difference between boilers and pressure vessels.
Mm-hmm.
So you can be consonant to the fact of it, if it's boiler proper or even boiler external pipe in here, there's some duly tighter limitations around that. And of course, you need to have the additional boiler certification for your ISI. So
yeah,
that's a good one for the certs episode when we get to that for sure. But yeah, again, going back to the cap too, you're going to be allowed to do certain things for piping, certain things for boiler external piping, certain things for pressure vessels, and certain things for boilers, and there could be a longer list for some than others, right? You may be very limited on boilers and have a wide range of pressure vessel repairs you can do. It's just knowing what you can do, and then again that the company you have contracted can do it. Like Div 2 vessels, for example, is a unique one where a lot of companies on site aren't certified to do that. So just really be careful of that. Make sure that they can do that, and obviously your ABSA is going to be quite involved with those ones too. So nothing too disastrous should happen there, but just be really aware of who can do what.
That's a good one, Scott.
Yeah, they really like to get involved with boilers, boiler external piping, and Div 2 vessels. We made that joke that they essentially own them, and the owner users operate them for them, right?
They think they own them. They definitely didn't pay for them, but they kind of own the title on them, if you will.
Yeah.
The owner users lease them from them, if you want to look at it that way.
Yeah. All right, let's move it along. That was pretty good. We're starting on this episode strong. I'm getting a little worried. I don't know.
Can only go down from here.
Yeah, exactly. Code of construction versus national board and the API codes for inspection and repair stuff.
That's a big one for Alberta. Again, this is an Alberta thing. ABSA is really big on, when you get into the repair realm, you're back to your code of construction. They're not real big on using national board and things like that to do repairs. They want you to follow code of construction. Now, when you can, a lot of times you can't. Temper bead and things like that aren't code of construction things per se. So there's a bit of leniency there, but one of the big things they talk about in our 513 document is not utilizing those. They're good reference material, good engineering practices, but they're not declared in force in Alberta. So they always want you going back to the code of construction. So just be cognizant of that. make sure you're accepting things to the code of construction, that type of thing. We did talk about not bringing it back to new, and you're not, but you essentially are following that new code of construction again. So that's kind of the gray area that we like to play in. But that's one thing to be aware of. National Board has got a lot of good ways to do repairs and good recommendations. A lot of them we can't follow here. We got to go to new construction first, and then see if we have no other choice, we can venture into those other things.
Yeah, well, API is good for that too, because like that's the verbiage in there is to the code of construction, right? Like they want you to go back to the code of construction, just like our regulator, like Scott just said.
A good handbook for repairs, just to jump in there, is ASME PCC 2.
Right.
Which gives you a really good bookmark and kind of index way, for an array of repairs, all through from mechanical repairs to welded repairs. So that's a really good starting point, I think. If you're building a repair plan, it's worth checking.
Yeah, it's a great reference material for sure, and kind of a good way to put that in perspective is like assessing flange faces, for example. Now, the inspection and assessment world is a little different. You're not necessarily at the new construction, going back to the code of construction for that stuff. So you can assess a flange face to PCC, but once you get into weld buildup and refinishing it, now you're back to your B165 or whatever the new construction code was. So you can't do weld buildup, machine it, and accept a whole bunch of pitting all over the place because it meets PCC. You're out of that world now. You've already blown through that one. You're back to ASME. So be aware of that. That one, flange face is a huge difference there. So just know what you're doing. Assessment time, that's fine to follow those. Once you get into the repair, not so much just the machining, but once you start weld repairing to fix that thing, you're not accepting it to PCC anymore. You're back to ASME. So I think that's a good example.
The PCC ones are actually pretty good, and they do actually have in there, like minimum raised face requirements and stuff like that, which you can use, but you got to be careful because, like, especially with our regulator and stuff like that, it's what they recognize as an approved document, or like Scott kind of mentioned earlier, like a reference document to perform repairs or stuff like that, especially on flange faces. And even if your flange face even does need repair, right? Because you do really commonly get corrosion on the portion of the flange face that sees service, right? Aside from your gasket seating side. And a lot of people call this the wetted portion, or I see that a lot in old reports, right? But like, you got to remember, a portion of your flange face is actually experiencing service conditions, and the remainder of it is actually your seating surface where your gasket sits. And more often than not, unless you have some I don't know, in my experience, it's normally like steam cutting or something like that, where you'll have it encroaching onto the seating surface where you actually will need to do the repairs. So take some time and assess it and determine if it actually needs to be repaired on the flange faces. And I don't want to sound too nonchalant about just letting flange faces go, but use your discretion, I guess, and determine whether or not that does need to be repaired. Because sometimes on these bigger flanges, or even on girth flanges and stuff on exchangers, like setting up the machine and well building up, like you might have a whole whack of other issues that might come up with performing that work, right?
Oh yeah, you can make it worse, right? So I mean, a lot of times your sealing surface will be fine, and it's that area where the inner ring sits that's corroded and pitted a little bit. I mean, is it going to make any difference to fix that? No, not really. It's still going to seal in the same spot.
Yeah.
And I mean, to your point about machining it and taking the bolt circle down and the raise face down, I mean, you're going to have your engineers involved crunching out some numbers there too. So that's a team effort as well.
Yeah, actually, one thing we came across this last turnaround too was actually when you do take down like the whole bolt face or something like that, you want to make sure that there's still enough room in there for your channel to actually properly seat, especially if one side is inset and the other side is like the kind of like a race face, and you want to make sure that you don't take too much down on the one side, else it's not going to actually seat, and then you got a whole other world of hurt.
Yeah, especially the raised portion, because then your gasket might not even crush now.
No,
right? Now you're a whole nother problem that you found at startup, and you don't want to be the guy that approved that.
No, definitely not. What do you think, Matt?
Oh no, I agree. That's when I blame the contractor.
I concur. Yeah,
that's where the fall guy comes in, no doubt. So
yeah, it's pretty easy. Pretty well. Just use your discretion and definitely get some second opinions and definitely talk to the engineers. API 660, even though I think it's a new construction code for exchangers, it's got a schwack of really good information on there, especially on seating surfaces and even some seating surface flatness variants, which I actually learned about this turnaround too. So, check it out. And even the company or the owner user you're working for, they might have some internal documents that actually have, flatness or some corrosion kind of assessment protocols that you can use to kind of use as a baseline reference to start. Well, actually, if they're those company kind of documents, you'll have to follow them, and ask around, make sure you know them, try and read them beforehand and get that information you need, because they're invaluable, especially during turnaround. Like if you can whip that out and be like, no, your corporate documents say this, like we might need to machine it, we might not. And even doing flatness checks on your on your flange faces and stuff like that, especially exchanger girth flanges and the channel side, like that is something that I kind of learned about a few years ago, and it can really help determine whether you actually need to repair that flange or not.
Oh, no doubt. And like there's a lot of great technology out there, like those ferro arms and things like that give you a nice 3D image and some really accurate dimensions. There's a lot of great technology out there, but I mean, a lot of these things will jump up on you surprised, and you won't be expecting it, but some of them you'll know, right? You might have a joint quilt or something, you're going to do some machining, maybe some welding there. So that stuff you could get out of the way early, know how much they can take down, have that info ready for your machining company. Frank mentioned the in-house practice and procedures. If those exist, and I can get to know those if you can, that type of thing. One thing I'll say about the code of construction versus in-service before we get off this topic is just have a look at the 513 document. It's kind of interesting how they speak to how the National Board and the API 510 are great reference documents, and then in the very next paragraph, or maybe it's vice versa, they say these are not declared in force and you can't use these. So I don't really know what their stance is on that, but to me, you shouldn't be using those once you get into the repair phase. So, I mean, just be aware of what's out there, and if you're not sure, talk to your authorized inspector too, right? That's what they're there for.
I think they kind of take stuff out of those documents and then the regulator takes it and creates their own documents out of it, basically, right? Like, because if you read them, they're almost extremely similar and like similar kind of verbiage and stuff like that.
Yeah, and they're all very opinionated people too, right? You'll get a different answer for a different one. I guess that's why you have one guy you answer to and not a team of them, because you'll get different answers.
Yeah. So, repairs versus alterations. What do you guys think?
Another good one.
Well, yeah, it's pretty good. But
what is the difference?
Repair, like we kind of said earlier in the episode here, is, you're bringing it back to a serviceable condition where it can operate safely. But also under that note in API, like adding certain nozzles and stuff like that, or replacing nozzles could be technically a repair, right?
Yeah, I mean, it depends on the size of the nozzle, depends on the corrosion around there, what you're doing it for. It depends if there's similar nozzles that you're adding, basically the same size nozzle. If you're upgrading a nozzle to a bigger size that doesn't exist on the vessel, now you're into alteration. So, I mean, the easiest way to remember this one is if you're bringing it back to a serviceable condition, like Frank keeps alluding to, that's essentially repair for the most part. And if you're changing the drawing, as a really simple way to look at it, usually an alteration, with some caveats in there, like we already talked about, like adding the nozzles. So if you're adding like a 2-inch nozzle to fix some corrosion maybe, or to just add another injection point or something, that can be considered a repair. Now you got to look at your owner user program a little bit for that too. You can even add bigger nozzles, like I mentioned too, as long as those already exist on the drawing. So you got to know the differences. If you're changing metallurgy, for the most part, that'll be an alteration. So a lot of times upgraded bundles is a popular one. Upgraded shells on exchanges, upgraded channel heads. Exchangers really in general is the thing we're going to be upgrading those components, and that'll be an alteration. So that's something your regulator has to be involved in. Now, are they going to want to be there to see much of the work happen? No, probably not. And they will more than likely just sign that off over an email, because there's not a lot for them to see. It's all been through design survey, and you're using a certified company to install the component, and they're more than likely going to certify that AB40. I don't know of too many companies that can certify alterations. I believe that goes against the APSA documents, not saying you can't go against them if your CAP has that, but I think that's one they kind of hold close to the heart, like the boilers. They hang on to that one. So just be aware of that type of thing, right? You're upgrading metallurgy. It's likely in the alteration stage. You're going to have alteration tracking number, all that stuff in place. It's likely been surveyed already. So just get your regulator involved, see what he wants to see. Maybe he wants to see the bundle. Maybe he doesn't. Maybe he just wants to sign it off. Maybe he wants you to do a leak test. Just get all that stuff hammered out beforehand and know what you can certify and what you can't, and make sure your company can actually certify the work too. Your repair company you have on site.
Yeah, no, I was just going to add to, if you want to remember alteration, any change to the nameplate or the data reports, let's say, any change to data on it is an alteration.
Yeah.
In short.
Or the way it operates, right?
That will be on the data report. So
Yeah.
any operating conditions or design conditions, material changes.
Yeah, great point with the nameplate.
Yeah, I was going to bring that
so
up.
We're both ready to arm wrestle to jump in there. But yeah, great point. Like the way ABSA looks at that, and this is Alberta thing again, is any alteration that's been surveyed has to have an alteration nameplate on it. Now, a lot of times that doesn't do you any good. It's just another piece of jewelry hanging there. But like you mentioned, when there's a change to the design or operating conditions, that's when that new alteration nameplate is going to be really relevant information. So not only do you have to put that nameplate on there, but you also have to cross out, you don't take off the original nameplate, that always stays there, but you have to cross out any of that design info that was changed. So say you upgraded your metallurgy to like an Inconel or something like that takes the heat really well. Now you can operate at, and your design conditions, both have been cranked up temperature-wise. So now your new alteration nameplate is going to have that stated on there. So what you have to do, as well as putting that on there, is you have to go back to that original nameplate and X out that information so it's no longer valid.
Yeah, and actually some places even have repair nameplates as well, right?
Yeah, sure. And I think that's a national board thing
Yeah.
too, getting to the repair code that we don't really use here. But for maybe our neighbors to the south, they're doing repairs to national board. They're big on the repair nameplates.
Yeah.
I think if we did that here, it'd be. I don't see the value in it. That's my personal opinion. Would you guys
Honestly,
agree?
for me, I've not seen many repair plates.
Yeah.
It does talk about it in 513.
I thought
you say in the States they ask about it, but on all practical reality, here I haven't seen next time.
I thought I'd chuck that in there, but realistically, there'd be exchangers just covered in nameplates.
Well, that's it. You'd run out of shell, right?
Yeah.
I think like a few examples I may have seen is they're doing like a coker stretch or a complete replacement of a huge component like that, where that's a repair that was altered a repair that was submitted to design survey, not an alteration. Things like that, you might have a repair on there because that's a significant reference, but you really didn't change any design conditions. So, there is very, very few of those. That's just something we don't do in Alberta. And yeah, in my opinion, you're not gaining anything by doing that. You're just putting more crap on there. And there's no benefit. Okay, somebody did some work on here. Great.
Yeah, I've seen a few like nameplate placards where there's like 6 or 7 different freaking alteration nameplates on there. Like, and you're sitting there trying to review like which one. Obviously, they're supposed to be X'd out, but like, there's been so much done to this piece of equipment, and some of them do have repair nameplates on them, right? So you're sitting there looking at this, trying to, confirm it with the last report or see what's happening or the most current report that you have, and trying to figure out when. Okay, well, the date on my report or the U1 that they gave us doesn't really match the nameplate that they have here. And then you're spending another half a day digging through files, trying to figure out what happened.
Like which one's relevant now. It just makes it confusing. I've seen the odd piece of new equipment that comes in with a national board with the R stamp on there with a repair that was done for whatever reason, something that got through manufacturing but shouldn't have, that type of thing. So that's a little unusual, but you see those things. But yeah, for the most part in Alberta, we don't slap on the repair nameplates, not too often.
No. Moving on. Jeez, wow.
That's a good conversation on the nameplates. We didn't have that written down. I'm glad we went there. That's That's a good one. I think people get hung up on. There was on this last outage, we did a couple nozzle jobs. One of them being an alteration with the bigger size, kind of we alluded to, and then the other ones just considered repairs because there was similar size ones on there. And Oh yeah, the Boilermaker company is very excited about, we need nameplates on there, and they're really hung up on that. But
It's free advertisement.
yeah, exactly, right? Maybe that's what they want. But yeah, so that's one just to know, right? Make sure when the nameplate has to be on there that it does go on there, like those alteration ones. And the only way you're getting out of that is to have a conversation with your authorized inspector. If he's okay with you not putting it on there, then you're okay. But definitely clear that with him first.
Yeah.
Him or her, I should say.
They. Next one is Scott's favorite one here. AB40 forms and turnover packages. So say we have determined that the vessel required a repair. We've developed our repair plan. We've issued it to our contractor. Do we need to get into any more detail on those steps following this AB40 forms and the turnover packs? Like, we've determined we had corrosion. It's not going to make the next run. We want to fix it via welding, or I guess, I don't know. What else can we do to it?
Yeah,
Weld it,
I mean,
or we could retube a bundle.
Yeah, retube. I guess if they're going there.
you know.
I mean, we had tube plugging on there as a side note. I guess we could jump into that for some example purposes. But yeah, I mean, I don't know what to say about this. The AB40 is going to be, essentially the last thing. That's something for people listening that aren't familiar with what these are, that's how you certify and wrap everything up. So that kind of comes after the fact. You have a turnover package to support it. We were talking off air about that being the evidence. That's kind of a good way of putting it. So your AB40 sums it up, and then your turnover pack's full of evidence of what they did there that validates the repair plan that you gave them. And in a perfect world, that all lines up. Sometimes these things get missed and you get non-conformances coming in and whatnot, but we'll leave that one alone for right now. But I mean, tube plugging's a good one. There's I've had arguments with people that poppet plugs don't require AB40s because there's no welding. That really isn't the intent of these forms. They want to know that the repairs you're doing, it doesn't really have anything to do with welding. It does, but it's when a repair's been done, right? So you're plugging tubes, mechanical or welding, these AB40s have to be done and submitted. There's different services that the welded plugs are better than poppet plugs. The poppet plugs are a little faster. I know the coordinators and the pushes really like those things.
Yeah.
What are your guys' kind of opinions on those ones?
Yeah, well, even during that same conversation, we were talking about how it's not as common practice to actually just do friction fit plugs anymore.
Right.
Now we're welding on the tube sheets. We're welding the plugs into the tubes and onto the tube sheets now because it's just better, right? There's less chance of them coming out during operation, and you're plugging those tubes for a reason because you don't think it's going to actually either hold pressure or it's not going to make your next run, or it's not going to last. And then you have the potential for process contamination, or even just sometimes your shell side's not rated for as much as your tube side is. Like, there was one exchanger where the shell side we plugged a bunch of tubes. The shell side was only rated for 200 PSI. The tubes are rated for 1400 PSI, right? Like, that's quite a bit of difference. And you definitely don't want the operating, well, I guess not the operating pressure, but like, you don't want to have that pressure leak into your tube or onto your shell side or vice versa, because that side of the equipment may not be able to handle that, right?
Yeah, and that depends on the process too, right?
Yeah.
I mean, sometimes that's really critical. Sometimes it isn't.
Yeah.
Maybe you're plugging tubes because you already have a hole and you know that there's a process leak. There's various reasons, right? Maybe you've got enough wall loss, you got to get rid of some. And then, I mean, you get to the whole conversation too. At some point, it's better just to retube the whole thing because you're going to essentially turn that into a big blind flange now and your efficiency's gone, right? So you really have to play that game a little bit too. There'll be your company you're at, they're going to have some kind of hard and fast rules of how much efficiency they're willing to lose. So that's where you got to start looking at the retube. But yeah, those are all conversations. Especially if you're expecting these repairs, you're going to have those already and kind of in plan. Like, okay, we can plug this many tubes. We did some iris inspection. We got to plug significantly more. Okay, maybe a new bundle is a better way to go about this now. So those are things you're likely going to be prepared for, I would say, in advance.
Yeah, I mean, for me, like, tube plugging is one of those. It's probably it's dead easy to complete, but probably has the most thought behind it. Just like you say, Scott, with the multi departments and talks that have to happen between process engineer and the operators, the maintenance group, the inspection group, you know, how many, when, how. Yeah, there's lots of conversations around that one for sure.
Yeah, really, it's the paper shuffling takes longer than the actual execution of the work for sure on those ones.
Yeah. And even knowing what the consequence of having a, you know, tube leaking, like Scott alluded to before, like, is it really going to matter? Some cases, yes. Some cases, no, depending. So definitely check with your process engineers or operations, most likely process engineers. But, you know, sometimes if you have a leak, it may throw another product off spec, and that might cost more to the company, because even though each shell side and tube side process sides aren't much different, like it may be a treated product versus a raw product going into, say, a hydro treater, like as preheat for the process, that you might contaminate it, and then they're stuck recirculating and losing money every month, which is something that I have worked on before. And like it just costs extra money and extra processing that doesn't need to be done. So verify that before I guess you guys start saying no, yes or no, if these need to be plugged or not plugged, and even the efficiency, like we alluded to, right? You want to know how many tubes you can actually plug before you start hindering the performance of that piece of equipment, because that is another huge factor of it. And there's a lot of frickin' calculation that goes into heat exchangers and their efficiency and ensuring that they stay efficient for the actual process.
Yeah, right. And really, like the number of tubes, the material, a lot of these things play a big factor. I mean, some you know, relatively small bundles, carbon steel, you can get a retube hammered out in a couple of days.
Yeah.
If you're fortunate enough to be in a city that has some, you know, vessel shops in the you know, same location. If you're shipping them off somewhere far away, maybe not so quickly, but yeah, a lot of places you can get a retube done in a couple of days. So you may be better off doing that than really knocking down your efficiency. So it's really a weighing game there on what you're dealing with and what you're going to end up with.
That actually fascinates me. Like one of my secret fantasies of the industry is like, I want to go and build an exchanger. Like I want a tube, like I want to build a bundle. Like I think that would it'd be fun. You know, people who maybe build bundles might be saying, what the hell is this guy doing sniffing glue all the time? But I think that would be a good experience, especially coming from being on a pipe fitter side, working in fab shops and being in the field and like taking stuff apart, piping obviously, but like, you know, I think building a bundle would be actually pretty fun.
Yeah, it is a fascinating process for sure, but it's probably like anything, it becomes an assembly line and it wouldn't be that exciting after a while, but yeah, it's definitely a fascinating process, especially those turnaround bundles where they want a retube done in a couple of days. Like it's quite amazing how quickly that can come in, get the tubes ripped out. It's like, especially a retube where you're not punching out a new channel head or a new tube sheet and everything. So it's quite a process, and it's really amazing how fast some of those shops can do that and get that back to you. And it's hydro tested, certified by the authorized inspector, ready to go. Just stab it in. So it's quite a process.
That's why I only want to build one, so I can keep that nostalgia about it, right? Yeah. So, yeah. I guess we touched on AB40s already. Do we need to go back with that, or?
I don't know if we go too detailed here. I think when we do our
vessel
repair kind of mini series, I think I want to get deep into that and how to fill those out. The one thing with those is find the guy on site that knows how to do those, the guy that's done them a lot, and just make sure you know what you're doing. I find a lot of people, especially that aren't doing a lot of turnarounds and that, don't know how these forms are filled out. A lot of the repair companies don't know how to fill these out properly. So there can be a lot of back and forth on these. So yeah, just make sure you're aware of how they're filled out. But I think we get more detail than that in a different episode. I could talk about that all night.
Yeah, maybe something quick to say is that these are the regulator's forms. They actually have additional forms that inform you on how to fill out the forms. So you could go and
great point.
You could go and see exactly what they're expecting for you to fill out on this form and how they want you to fill out the form. And it's it's not even that hard of a document. It's essentially a paint by numbers document where they say, this is what we want in this section. This is our interpretation of it. Put this in this section. And you should be able to do it if you're following your ITP. And actually, one thing that I wanted to actually say was when we've been talking about ITPs as mainly like a QC function, almost like a QC checklist, like we mentioned in...
Great way of putting it. Yeah.
I think it was like maybe our first or second episode. But also the repair plan that we create as in-service inspectors is kind of like an inspection test plan, because that's what we want to see. Like I said, I'll take what we wrote out to give to the contractor to create their ITP and make sure that they've met all the requirements. And this is something you should actually do when you do your initial sign up of the ITP, where you say, you put your lovely name at the top, and then you put your hold points, your review points, your verify points, and your witness points. I guess those are the most common ones, depending on where you are, or who you work for. You might have some different, terminology. Yeah. I knew we brought you here for something, right? No, perfect terminology. Or so, double check that and make your ITP for them nice and concise, and everybody knows what to do, and you get a good product coming out of that.
Yeah. And really they should build off each other. Like your repair plan is, somewhat of a checklist, if you will, too, of what you want done. You might have some bit of information there, what you want done, what needs to happen. Then the ITP should, to some effect, mirror that. It'll be even more checklist form, because that's essentially what it is, as a checklist. And it should cover everything that you've wanted. Everything that you've missed should also be covered in there. And then everything that they need to do to satisfy their quality manual. So there'll be some additional things. So if the ITP has far less information than your repair plan, right away you've got a problem. That should never be the case.
Yeah, no, definitely. I see the next thing also on the board is fitness for service. We have that written under our AB40s.
Yeah, I think that was an afterthought that we kind of already talked about, because we got corrosion rate and remaining corrosion allowance and those things on there too. I think we beat that one up maybe not enough, but enough.
Enough, yeah. We're already 55 minutes deep, I think, in this.
We got to close this Manway already.
Yeah, no. Oh, that's a good sign off. We got to remember that. So, you can do fitness for service essentially if you're not going to repair something. So it's very detailed, and it's mathematically intensive to perform some fitness for service stuff if you don't want to repair it maybe this cycle, but it gives you enough time to plan for your next turnaround cycle to execute those repairs. You might need some specific material if it's a bundle, or the lead time for certain components that might be corroded, like a nozzle or something, or the material of a nozzle. This kind of stuff you can do. The engineers love doing it, I guess. I think it's math. I think they
get super excited.
Yeah.
Like a couple of quick examples would be like, you're going to replace a component anyways, but it hasn't shown up for this turnaround. You're going to do it next turnaround.
Yeah.
But you've got some decent corrosion there. You want to make sure that's going to make it. Another example would be, not really an example, but I would just want to say for your Div 2 stuff, just to make sure that stuff has to be submitted to design surveys. So just be aware of that too. And anytime you're messing around with that Div 2 stuff, make sure the regulator's involved, because you'll have to submit your fitness for service calcs. They'll review it, make sure it's all good. There's not a lot they're going to do to stop you unless you've done something really wrong, but just make sure you got to submit those too.
Yeah.
Yeah, I was actually going to say, I think for fitness for services, they're all regarded as alterations, right? So
right, exactly.
So
right.
It'll all go through design survey, and really it's just a way up case. Is it easy to repair something, or easier to maybe do a fitness for service? And
that's actually a really good point. And actually,
I won't say easier. That's probably too slack of a word. But what's the best for getting back in production and operating as a business for the next 4 years?
Yeah, and re-rating a vessel too. That'd be an alteration, right?
Re-rating is an alteration,
right? And you definitely need a new nameplate for that one, right? So.
Yeah, and it depends what you're re-rating too. I mean, some places can re-rate piping without talking to the regulator. Some places can't. Not too many places you can re-rate pressure equipment without getting that surveyed. So just make sure you know what lines you're crossing there, and don't get too far over there without informing the proper people. Being the regulator.
Yeah, and being a claw kind of plucked inspector, you're not going to have to worry too much, but you should definitely be aware of what the requirements of a re-rate and stuff like that are. So,
well, if you're on a claw job, don't worry about this stuff. 'Cause you'll have nothing. You'll have zero input in that.
you definitely won't have input on it, but
No, you won't even be aware of what they're doing in the background. So just forget all this. If you're on one of those jobs, you're there to look at stuff and write it down and get out.
all right.
All right, let's close this Manway already.
Yeah. Okay. Let's go, Scott. Take us through it, or Matt. Either one.
Let's. Yeah. Well, I don't know. I can give the my take on a few different sites. Like the biggest thing with this would be knowing. So I would say the most common thing is like a closure book type of thing where there's gonna be various people signing it before they can close a Manway, and this is where you'll be getting screamed at by all kinds of people to come sign the closure book. Now, the biggest thing with this, I would say, is knowing what the steps are for the site you're on. Some places are going to let you sign the closure book whenever you think it's ready. Some places are going to want the AB40s, the turnover packages, the ITPs signed off. They're going to want their SRBI or their RBI programs updated. They're going to want their next inspection date set. In my opinion, that's the way to do it, is have all those things in place. Now, sometimes that's not always practical to expect that. So, there's one extreme to the other, and then there's everything in the middle. Maybe Matt, you could give your take on what your facility likes to do. But I've kind of seen a lot of everything. I really like the extreme where everything's signed off, because then there's very little chance of egg on the face there. And sometimes what's relevant and what isn't, right? I think at a minimum you want your next inspection date cranked out and make sure you're not going to be opening this thing again in 6 months, because that's not good either. You don't want to be the guy that made that call.
No.
And Scott, like we were discussing there offline a little while ago before we started this episode, I was saying how for us, or for me, I guess personally, I like to think the closure is somewhat the easiest part of the turnaround, because if you've been on point from the beginning and through the middle to the end, and understanding what's happened to your equipment, what inspections have been completed, what's been seen and done, and what's been accepted, really when it comes to closure, you should, hopefully, if we're all professional, we shouldn't be scrambling around at that point looking for things.
Shouldn't be.
You should have some good self-confidence that the job's been done, everything that has been found has been dealt with, and you're able to move on and close a piece of equipment and make some money. I mean, for me, for the RBI part, that's certainly after the fact. There's a lot of thought and documentation that goes into that. I'm not so sure I'd be completing that up front. But for me, get the 8 regulatory forms for sure.
Mm-hmm.
As much turnover as you can manage, and what's reasonable with the workload that was completed. And I'd be happy to sign off on that for sure.
Yeah, and it puts a different amount of pressure on your repair contractors too. Like which kind of takes the pressure off of us, I guess, so which is nice. So if you're one of those places that wants every ITP and every AB40 or whatever other form signed off before they can close that Manway, it should be putting all the pressure on them, because our inspections will be done well before that. And there's no reason your corrosion rates and your next inspection date shouldn't be cranked out by then, no problem, right? So it really does put it back to the contractor. But I mean, to be fair to them, they got to know that expectation up front too. It can't be when the Manway's halfway swung shut, now all of a sudden, okay, where's the paperwork? So you got to be upfront with those things too.
Oh, for sure. And the I want to say high charge motivation to shut Manways usually means the company spent more money than it had. It needs to get back operating pretty quick.
And I think just make sure that you have a plan, especially within the inspection group on turnarounds, that when you're actually going to sign the closure book, because it is relentless when they actually want to close a vessel, and inspections is they need, it's usually inspections, process engineering, and operations, right?
Yeah, and then the coordinators are the push people, but they sign that thing the day it opens. So
yeah, but like It is relentless. You'll have the coordinators, you'll have operators, you'll have frickin' stray dogs on site coming up to you to ask you to sign that frickin' closure book just so they can move on and say it's done and progress the schedule, right? But have a method. Like if it's not until the AB40s are signed, or your closure, or your repair or whatever packages are finally reviewed and ready to turn back over, make sure as like an inspection group you guys say that, because as soon as you crack on one vessel, it's just going to come hammering down, and like they are freaking relentless. I think in a span of like 2 or 3 hours on this last turnaround, I think 8 different people came to ask me about closing a vessel, and it wasn't even ready yet. They just wanted it preemptively ready to sign. So once it was like, once the, that exchanger, once the bundle was like an inch in, they had another crane already with the frickin' channel hooked up to it, ready to swing it in and slam it shut. Like, have a hard, fast thing and stick to it. And that way you make sure you feel good about yourself when you close it, that you've captured everything that you need to capture, and that the vessel their piece of equipment is good to run for that next period of time of however long it needs to run. And you're not sitting there, scratching your head saying, hey, did we do this right? Or do I feel good about actually completing this? Which is something that might sound, I guess, kind of a little wonky, but like you do want to feel good about the work you perform and make sure you do the best job that you can and make sure that it's sound, because there is people walking by this stuff and it might be you one day, you know what I mean? So
yeah, and you want to feel comfortable about closing that. If you're not, and your tracker's out to date and you're really confused at where it's at, don't close that manway, because you don't want to open it again. The manway gets open once, it doesn't get open a second time. So, and then another point with that, just know who can sign those things too, right? Just because you're in the inspections team doesn't mean you can sign for a closure. Some places I've worked at want you to have your absolute in service. You want to be one of those guys to sign it for whatever reason. That's what they like. Other places, it'll only be the staff people, which makes sense too, right? They're probably more familiar with the place. Other places, it'll be, only the lead for that team. So just really know who can sign that, because you'll get people that, they'll say it's the example where it's only the lead guy that can sign it. He'll say no, and then the next guy will get radioed, and then the next guy will get radioed, and until somebody cracks.
Just wait for shift change.
Yeah, until somebody comes and signs it, right? So if you're not allowed to sign that thing, make sure you're aware of that and don't sign it. There's a reason only certain people can sign those.
Yeah, and I was just going to add a kind of, I guess, bit of practicality to it or not. But for where we work at now, just because of the mayhem that's involved in getting closure forms signed by various groups, we always book a meeting and host a meeting. And it's, rightly or wrongly, it's turned to a bit of if you're there, you get signed, and if you're not, well, get lost. So it works out, you book your operator, your process engineer, your inspector for the unit to show up at 2:00, whatever. We're going to go look at this equipment and close a manway and sign a form. Where if you don't show up, then unfortunately you just get a little NA by your name and we move on.
Oh, that's interesting. I don't even want to comment on that.
No, it's their facility. That's their way of doing things, right? So,
you'll get held to account after the fact. Don't worry.
Yeah.
But times are moving.
Yeah.
People are pushing. So
yeah, I guess just to that, know the facility and know what the rules are behind that. The operations, the coordinators, those people might have different rules for when they're comfortable signing a closure for a manway. If you're part of the inspection team, know what those rules are, know what that comfort level is. I think that's the big takeaway from this conversation.
Yeah, it's usually those maintenance guys like, didn't you walk by that vessel? Didn't you look inside of it and write a report already? Like, let's get it done. So I think that's it. What do you guys, anything else to add? I see now there's a little bit of glare on the whiteboard there from the lighting, but there is a little arrow going from those AB forms down, or AB40 forms down to the turnover packs there. So
yeah, I think we just kind of talked about that later. If you're at one of those places that like the turnovers in and signed off before the manway can be closed, some of the difficulties you might have with that is, the big companies with the big dock control teams, that's probably not as big a concern because you're getting that paperwork quickly and getting it turned over quickly. If you're these smaller cap outfits that has one QC guy that's also the dock control team and also the NDE guy and is wearing all these hats, good luck getting that turnover quickly. That's just not going to happen. So that maybe that's one where you want to revisit things. So you just want to have a good plan for those. You don't want to be beating that guy up too badly and make him think he's holding up the whole show.
No, I just think you need a balanced approach, to all of this really in terms of the scale and the amount of work and the number of hours that have gone into something is to, how much do I die on a hill at the end of it all, And I'm not saying, you do things wrong. It's just you got to balance up. If it is a very large-scale turnaround, tons of man-hours have gone into this, lots of people are involved. Like you say, Scott, very unlikely to have everything that you want at the end, at that point when you want to close a Manway. And so, those discussions should be up front too. And like I say, be comfortable where you're at and always give the contractor a deadline, 2 weeks after, 3 weeks after. We want to have, the paperwork there road.
Yeah, kind of weigh out the wants versus the needs. I mean, it's sure it'd be nice to have all that stuff. Is it a reality? Maybe sometimes, but sometimes not. So
if you want to be invited back, sign it.
Well, one thing you could actually also do is just assign hold points on the critical items on that ITP, like NDE approval or NDE review and stuff like that, and the hydros and stuff. And if you know that package is going to be delayed, at least you've laid eyes on those documents and verified that they're clear to go. And then that way, when you do get your AB40 or whatever later after the vessel's complete, you've been involved in the steps of that job, and you can, with certainty, sign that AB40 or AB83 even with confidence, knowing that the job has been completed as per the plan.
That's a great point, Frank. And, what I was trying to allude to earlier, as long as you've been a part of it and you've been in it and you've been on point from the beginning, then, at the closure time, you should have good confidence in yourself and the group and the team that you've all, fulfilled the duties that need to be done to ensure this equipment is safe for return.
Cool. I think that's it. Does that sound... what else can we talk? I guess we could talk about turnaround all day, but realistically, we got to put a cap on it at some point.
Well, I think it's a good way of wrapping it up. I mean, there's a lot of post work and those things, but maybe we'll dive back into that later at some other point. But I think as far as the kind of turnaround life cycle, as far as the mechanical window and a little bit of planning thrown in there, I don't know. I think we wrapped it up pretty good, or did a good job of 4 or 5 episodes worth. So
yeah. It was pretty good.
Yeah, go back and listen to them in order if you want. We kind of kept it, event orientated, what happens first type of thing, and added to it as we went, overlapped a lot. So that's it. Manway's closed.
Yeah, good.
Send in that last invoice and get off site.
Thank you, everybody, for listening. Don't forget to share. Hit us up on Instagram, LinkedIn, and also you could visit our website and give us a shout if you want to hear about anything else. And I guess our sign off for today would be Manways don't open twice, right?
No, they don't.
Yeah. Thanks, everybody. Talk to you guys later.